Across our planet, storms are among the most powerful and fascinating forces of nature. They can be beautiful from afar, swirling clouds illuminated by lightning, yet terrifying up close, capable of reshaping entire landscapes in a matter of hours. But what exactly causes a storm to form? What turns a calm patch of sky into a roaring, spinning system of wind, rain, and thunder? To understand storms, we must begin with the very heart of Earth's atmosphere, where heat, air, and motion constantly dance in a delicate but volatile balance. At its core, every storm begins with energy, and that energy comes from the sun. When sunlight warms the surface of the Earth, it doesn't do so evenly. Land heats faster than water. Equatorial regions receive more direct sunlight than the poles. And even within small areas, forests, oceans, and deserts absorb heat differently. This uneven heating creates differences in air temperature and pressure, and those differences drive wind, the movement of air from high-pressure zones to low-pressure zones. Where there's movement, there's energy, and when enough energy builds up, a storm is born. One of the simplest and most common forms of storms begins with something familiar: rising warm air. Warm air is lighter than cold air, so it tends to rise. As it rises, it carries moisture from the Earth's surface, especially from oceans, lakes, or moist ground. The higher it goes, the cooler it becomes. And that cooling causes the moisture to condense into tiny droplets, forming clouds. If the upward motion continues strongly enough, those clouds grow larger and denser, becoming cumulonimbus clouds, the towering giants of the atmosphere that can reach heights of over 15 kilometers. Inside these clouds, powerful updrafts and downdrafts create turbulence, lightning, thunder, and heavy rainfall. This is the birth of a thunderstorm. But storms come in many forms. Not all are thunder and lightning. Some swirl gently across the ocean for days before exploding into hurricanes. Others tear through open plains as twisting funnels of destruction. What unites them all is energy, the continuous exchange of heat and moisture between the Earth's surface and the atmosphere. Let's look at how tropical storms form, the massive systems that become hurricanes or typhoons. They start over warm ocean waters, typically at least 26 degrees Celsius, where sunlight has heated the surface for months. The warm water evaporates rapidly, filling the air with moisture. As this humid air rises and cools, the water vapor condenses into tiny droplets, forming clouds, releasing even more latent heat, energy hidden in the phase change of water. That heat warms the surrounding air, making it rise even faster, creating a cycle of rising warm air and falling cooler air. When conditions are right, the system begins to rotate due to the Coriolis effect caused by Earth's rotation. This spinning draws in more air, lowering the pressure at the center and increasing wind speeds. Over time, a simple cluster of thunderstorms transforms into a tropical cyclone, a self-sustaining engine of heat and motion. Inside a mature hurricane, wind speeds can exceed 250 kilometers per hour. Rain bands stretch for hundreds of kilometers, and the storm's eye, calm and eerie, can span 30 to 50 kilometers across. The entire system can release more energy in one day than all the world's power plants combined. Yet, despite its violence, a hurricane is not chaos. It's an expression of balance, nature's attempt to redistribute heat from the equator toward the poles. Not all storms form over oceans. On land, rapid heating and cooling can create violent weather of their own. In large, open regions like the Great Plains of North America, conditions often align for the birth of tornadoes. These form when warm, moist air near the surface meets cold, dry air from above. The contrast creates instability, a battle of temperatures and densities. Strong winds aloft can start the air spinning horizontally, like a rolling tube. Then powerful updrafts from thunderstorms tilt that spinning air vertically, forming a mesocyclone, the rotating core of a supercell thunderstorm. If the rotation intensifies and extends downward, a tornado forms, touching the ground as a violently spinning column of air. It may last only minutes, but its winds can exceed 400 kilometers per hour, capable of lifting cars and shredding entire buildings. Meanwhile, other storms are quieter, but no less important, such as monsoons, vast seasonal systems that govern the climate of entire continents. Monsoons occur when large-scale temperature differences between land and ocean cause air to flow seasonally, bringing months of heavy rain, followed by months of dryness. In South Asia, for example, the summer monsoon feeds billions of people with life-giving rain, while its failure can mean drought and famine. These too are storms, not born from destruction, but from the essential rhythm of Earth's breathing. At the poles, storms take a different form. When cold, dense air from the Arctic or Antarctic meets warmer air from lower latitudes, the collision creates mid-latitude cyclones. These sprawling systems can stretch thousands of kilometers across and bring intense snow, freezing rain, and fierce winds to entire continents. Unlike tropical storms, they feed on contrasts in temperature, not ocean heat. Yet the result is the same: energy seeking equilibrium, chaos turning back into balance. What's remarkable about storms is that they are not just destructive. They are part of how our planet maintains balance. Without storms, the tropics would grow unbearably hot, while the poles froze even harder. Storms move heat, moisture, and nutrients around the planet. They clean the atmosphere, replenish water supplies, and even help distribute dust and minerals that fertilize ecosystems. In many ways, storms are the planet's heartbeat, turbulent, unpredictable, but essential to life. Still, as our world warms, storms are changing. Climate scientists have observed that warmer oceans and rising air temperatures provide more energy for tropical storms. This doesn't necessarily mean more storms overall, but it does mean stronger ones. Category 4 and 5 hurricanes are becoming more frequent. Rainfall within storms is intensifying, and their paths are shifting. Even slow-moving storms, which once simply rained themselves out, now linger longer over land, causing catastrophic flooding. The balance of energy that drives storms is being altered, and with it, the rhythm of Earth's weather. Understanding storms means understanding our planet's fragile equilibrium. A storm is not merely a random outburst of chaos. It's the atmosphere responding to imbalance, trying in its own violent way to restore harmony. Every gust of wind, every drop of rain, and every flash of lightning is part of a vast, interconnected system that has existed for billions of years. So the next time you see dark clouds rolling in, remember, what you're witnessing is more than just bad weather. You're seeing the living machinery of the planet at work, a colossal engine powered by sunlight, rotation, and the eternal push and pull between heat and cold. A storm may rage, it may destroy, but it also renews. It reminds us that the Earth is alive, dynamic, and forever in motion. Don't forget to like, share, and subscribe to WiseUse, where science and wonder meet, revealing the hidden forces that shape our world.